In this lecture, we'll be talking about wallets. When creating a wallet, we always need a private key and public key. Let's say person A sends to person B. The process involves signing the private key to validate the transaction. We need to see if person A really did send to person B. When trying to verify this, we need to refer to these keys. We have two types of keys, and one is private key and other is public key. We need to generate both of these. Here we have blockchain address, but this refers to person A's blockchain address. We generate by referring to the public key. This private key and public key are displayed as a pair here. But to get started, we first need to create these two keys. How these keys will be used is best understood by writing the code for these. For now, remembering that creating a private key and public key is necessary is enough. Next, we'll go over the general use of public key and private key. For example, let's say we have the text "Hello World." When we encrypt this, we use public key to encrypt. Let's say that this string is the encrypted code. When we want to decrypt, we'll use private key to decrypt and be able to see "Hello World" again. When we want to encrypt, we refer to public key. When we want to decrypt, we refer to private key. That's how public keys and private keys are generally used. With regards to Bitcoin, the use of public key and private key is a little different, but these two keys are used and referred to as a pair. After we process something in one direction, then we use the opposing key to process it in the other direction. The key concept here is that these keys work as a pair. Now let's move on to our next slide. This is a slide illustrating how transactions are processed in an actual Bitcoin transaction. This may look a little confusing right now, so while we're writing our code, I'll refer back to the slide to explain the process of the transaction. We create person A's public key and private key. Using this private key, we'll validate person A's transaction. We have the signature and the public key. We'll attach these two together and also add on our transaction. We'll group these three items and pass it on to our blockchain node. Now in our blockchain node, we have our transaction, and to see if this transaction is valid, we refer to person A's public key, signature, and the transaction. We'll do signature verification, and once that's completed, we can say that the transaction has been authenticated. For example, if someone wanted to do an illegal transaction and send $1 million to themselves, they might rewrite the transaction here. But here, what person A signed off on when they first created the public key won't match the rewritten transaction. That's why the blockchain node will catch onto this and not authenticate it. This may sound complicated, so we'll explain while we're writing our code. Regarding this public key, this has been made public, but the signature can't be generated unless we have a private key. So if person A's private key is hacked into by this hacker, then we have a problem. The system is made so that no one can guess, based off of the public key, what the private key is. Let's get more into this right now with our next slide. In Bitcoin, we have ECDSA, which stands for Electric Curve Digital Signature Algorithm, which is an algorithm to ensure that funds can only be spent by their rightful owners. We have a 256-bit elliptic curve. We use this curve to generate our private key and public key. For example, we have point P, and let's say that this is our private key. We'll refer to this coordinate to generate our private key. Then we'll create a line passing through our elliptic curve. The intersecting points are identified as Q and R. We'll take this point Q and bring it down. Then we'll again take this point P and Q to create a line that passes through these points. We repeat these steps and will result in many point Qs and point Rs. Let's say that we end up with a point Q here. We'll use this to generate our public key. Even if this point Q is revealed to someone else, it's quite difficult to derive point P based on point Q. That's why we create both private key and public key as a pair. Understanding this involves complex mathematics, so please just keep in mind that private keys and public keys are generated with the use of ECDSA and P256. Now with this in mind, let's start creating our private key and public key.